Welcome to Unit 3.2, My Body, My Cells. I'm Diana Lindsay. In the last video, we talked about the need to take charge in our own healing. But what are we in charge of? We are the voice of our cells. No one else can feel and sense them the way we do. How many are there? Well, scientists vary on that number, but current estimates are between 30 and 100 trillion. Regardless of the number, and with the exception of red blood cells, most human cells have a nucleus, which contains paired chromosomes, one normally inherited from each of our parents. At least that's the story we all learned. Researchers have recently found neurons within the human brain that contain DNA that apparently doesn't belong to either parent. So the story of who we are and what we're in charge of continues to evolve. Our chromosomes are made of tightly coiled strands of DNA, and certain segments of that DNA represent specific genes. Genes contain the instructions for making proteins, which are the building blocks of life. It's commonly said that the human genome is the instruction manual, and genes are the blueprints. This may be so, but sometimes blueprints are inaccurate, and sometimes so are genes. A mutation in a gene can be caused by either the environment or simply a bad autocorrect when the gene replicates during cell division, and spell check, for whatever reason, happens to be turned off that day. Most mutations are harmless, and some are even beneficial. It's how we've evolved, after all. But some turn a normally well-behaved gene into an oncogene, such as EGFR, HER2, and BRCA1 that you may have heard about in the press, which when turned on can lead to tumor growth. These oncogenes nevertheless follow a path. They don't immediately turn into cancer. We also have something called tumor suppressor genes, which are just as subject to mutation as any other. A tumor suppressor gene acts like a brake, bringing cell division to a halt if it detects any DNA that's been damaged during replication. This is a first line of defense against a potentially dangerous cancerous process. So if the tumor suppressor gene is either turned off or is itself adversely mutated, the body loses some protection. And this is the case in the gene TP53. The goal of medicine for the past decades has been to get to the next level of personalized medicine. Each of us would be treated according to our individual genetic makeup, including any identifiable mutations within that makeup. And to that end, initiatives like the Human Genome Project and the Cancer Genome Atlas have strived to understand in greater detail exactly what we've got. This cartoon illustrates the hope that in the process we would come to understand the answer to that most profound question, who are we? But has it really turned out that way? I go to my own story and its recent history to give you just a sense of what it's like if you had to walk in the doors of a modern-day genetics clinic. When I was first diagnosed with cancer in 2006, genetic testing wasn't standard care. Now it's routine for any cancer that has an associated treatment based on a genetic mutation, even though those are relatively rare. I was lucky. There was a drug called Tarceva that was targeted to my specific EGFR mutation. Even so, Tarceva was approved in 2004 based on only a 2-month gain. So in 2006, it didn't look to be the big panacea that they had hoped. It turned out that in patients like me, non-smokers with no prior chemo treatment, that Tarceva could be effective for longer. But ultimately, cancer is adaptive, while any drug is inert. The cancer can mutate, the treatment cannot. When the growth of a cancer with an EGFR mutation is stymied, it will often subsequently exhibit a second mutation called T790, and this is what happened to me. Just last year, my whole exome was tested for my family's sake. Now, the exome is just the part of the genome that codes for proteins. In other words, just the gene-related DNA and none of the so-called junk DNA. The researchers determined that I have a germline, meaning inheritable mutation, called TP53, which is one of the tumor suppressor genes we just looked at. This TP53 gene is a good guy, so the fact that mine was mutated and not working meant that I had lost the use of a good guy. Dr. Heather Wakely at Stanford says that we can test the exome, but we won't know for another 5 to 10 years what to do with it. And that's what I found. Right now, there are no recommendations for either prevention or treatment when you go in for genetic counseling for something like this, other than more frequent screening. The Angelina Jolie case is a very limited one. So the story of personalized medicine still has some writing to come. In fact, Craig Venter, the Human Genome Project director, recognized this at the end of it. Genes are absolutely not our fate. They can give us useful information about the increased risk of a disease, but in most cases they will not determine the actual cause of the disease or the actual incidence of somebody getting it. Most biology will come from the complex interactions of all the proteins and cells working with environmental factors not driven directly by the genetic code. So this is when we come to something called epigenetics. Epi means above, so above the gene. Epigenes are essentially molecular switches that attach themselves on top of the genes and determine if and when a specific gene gets turned on or off. The common metaphor is that the epigenes are the contractors who, using the blueprints of the genes, decide what actually gets built. This slide is more detailed than necessary for the purposes of this discussion, but the upshot is that the known epigenetic mechanisms are activated by certain molecules in the immediate environment of the cell. This environment, and therefore the epigenetics that govern gene expression, is affected by many factors and processes, such as environmental chemicals, drugs, pharmaceuticals, aging, and diet. The study of epigenetics is helping us understand that genetic mutation accounts for only 5 to 10% of a disease like cancer, and the remaining 90 to 95% are caused by environmental factors such as behavior, thinking, lifestyle, diet, and infections. Sometimes the epigenetic factor attaches itself to the DNA backbone, and indeed research has shown that epigenetic change can be passed down from parent to child. Research has also shown that even traumatic experiences in our past, and not just our own past, but those of our recent ancestors like our mother or our grandmother, can leave molecular scars on our DNA. So they've found that Jews whose great-grandparents were chased from their Russian shtetls have epigenetic changes. So do Chinese whose grandparents lived through the ravages of the Cultural Revolution. And young immigrants from Africa whose parents survived massacres also carry with them more than just memories. Studies of rats have shown that epigenes can be impacted by maternal behavior. Good mothering, licking, and grooming can reduce stress hormone levels in their offspring, and this can be registered and passed on to the next generation. But what's interesting is that a good mother can reverse the effects of bad mothering if she subsequently cares for a previously deprived baby rat. Methylation is the name for one epigenetic mechanism in which a methyl group, called CH3, attaches to the gene in a way that keeps the gene turned off. Studies of humans have shown that our epigenes can be impacted by poverty or wealth. In one study, researchers found that out of 20,000 genes, some 6,176 had methylation changes in the poverty-stricken, and this is twice as likely to occur in childhood. So as much as what happens can impact our genes, our behavior can undo it. And this, to me, is the tremendous hope that mind-body healing could do, that we could literally change our inheritance. Now, let's look at the next level up, the actual cell. The cell is an absolute marvel. They are adapted to change, they are resilient in the face of change, and they are redundant, so if something happens to some of them, others can take over. When the researchers told me that I carried this TP53 adversely mutated tumor suppressor gene, their faces were long, but my first thought was, well, where's the redundancy for this in the human body? Nature doesn't just give us one mechanism. The redundant system is there somewhere, even if not yet identified, and I wanted to find it and boost it. The common needs for the cell, for water, for nutrients, energy, waste disposal, have been sources of imagery for me. I love to visualize my healthy cells as resilient. I love to feel the sensation of energy moving through my body. And I love to visualize water flowing between the cells. And how it flows around the body is through the extracellular matrix, another area of ongoing cancer research. Surprisingly, very few of our cells actually touch each other. There's a layer in between, and this layer is very important for our survival because it's how nutrients get to where they need to go and how waste is carried away. It's also vital for the communications between cells. Cells do communicate with each other, and just like humans, some do it well and some do it badly. The extracellular matrix is also, unfortunately, a medium in which things like cancer can proliferate, especially when inflammation changes the microenvironment. Now, so far we've been talking about our DNA, our cells, our extracellular matrix, but what we're just beginning to understand is there's more to us than that. We've also got something called the microbiome, and in fact we have more than 10 times the bacteria in and on our body that we actually have cells. These bacteria have just under 3.3 million genes collectively, which is more than 150 times the 20 to 25,000 genes we have in our own DNA. And these bacteria can impact our health both positively and negatively. They can impact how we think and how we feel. And there are many things that we do that impact them and impact how happy the bacteria are. Good bacteria can influence the immune system. Sensitivity to antigens, bad bacteria can cause disease. As we develop, our cells specialize into our organs, and this is usually the level that we are sensitive to. We can feel shortness of breath in our lungs. We can feel our hearts pump hard. And we can feel them ache in more than just a metaphorical way. We can feel bloating and pain in our intestines, and we can feel when our livers are extended and in trouble. This is also the area that I've learned through Qigong that we can learn to feel pleasurable sensation. We can learn to communicate with these organs by sensing how well they're doing, even before they have to tell us about pain. So it's worth taking the time to understand and know just where in your body each of these vital organs are. These organs are associated with more extensive systems: circulatory, digestive, nervous, muscular, skeletal. These I'm sure you're all familiar with. You might be less familiar with something like our endocrine system, which consists of 8 major glands that secrete hormones into the blood. These hormones in turn travel to different tissues and regulate various bodily functions, such as metabolism, growth, and sexual function. Take the time, especially, to think about your immune system, how pervasive it is throughout the body, and where its key organs are, like the thymus and the spleen. As with the organs, familiarize yourself with these systems and begin to think about the body as a whole, with all of these systems contributing to your well-being. Let me tell you how that actually worked in our family when my mother got sick, or in her case, when it didn't work as well. My mother had long had heart issues that she inherited, but in truth, that wasn't the major issue, nor was it something she paid much attention to. Her digestive system was starting to have some problems. She was experiencing bleeding, but again, she did not go to the doctor. It wasn't until her immune system started to fail and she got what she thought that was a bad flu and virus that she started to feel bad. She tried to get to the doctor, but she couldn't get in for another 2 months. She decided to wait instead of going somewhere else. During that time, her lymphatic system, her skeletal system, her respiratory system, and her urinary system all began to show trouble. And it was the failure of the urinary system that finally sent her to the hospital. My mother saw a lot of doctors in the hospital, specialists who only focused on their area of expertise, and hospitalists who focused only on how my mother was doing the 1 day a week they worked. It felt like no one was looking at the whole. Finally, I drew a picture of her whole body with arrows pointing into each of these systems and included the tests that had been done and the tests that remained to do. And when I finally showed that picture to one doctor, he paused, he thought, and then he asked, "Has she ever been tested for multiple myeloma?" We got the results of all the tests for multiple myeloma, a cancer of the blood, at 6 a.m. one morning. She died that night. Interestingly, where Western medicine thinks in terms of 12 body systems, Eastern medicine thinks in terms of 12 primary organ meridians. In both disciplines, the system or meridian is concerned with more than the function and relationships of an organ than just the organ itself. Neither discipline is more or less analytical than the other, neither more or less right or wrong. There are simply two different ways of approaching medicine, each hanging from its own well-grounded framework. While they may not be precise correlates of each other, they're definitely complements. In traditional Chinese medicine, the 12 organ meridians are paired. The lung, for example, works with the large intestine. The heart works with the small intestine. The kidney with the bladder, and so on, each balancing the other. The specifics are fascinating, but beyond the scope of our course. As a gross generalization, the Chinese traditions are relationship-based, where the issue of cause and effect is not only murky, but largely irrelevant. Now, evolutionarily, life has been driven by two key imperatives: to grow and reproduce, or put another way, to learn and love. And the second, to protect. The body has evolved to give preference to protection. The example that's always used is if you're running away from a saber-toothed tiger, it doesn't really matter if the virus you have is going to give you a cold. But if our bodies are continually stressed and feeling like they always have to be in protection mode, we aren't going to be as healthy and happy in the long run as if we can balance that out with more emphasis towards growth and protection and reproduction. So in your journals this week, think about what your body is telling you now. Just now, this minute, not as a long history. Are any of your organs trying to communicate with you? What are they saying? In the next unit, we'll begin the process of deepening our dialogue with them. But for the moment, see you in the next video.